Hey everyone, what's good? So today, we're diving into something absolutely mind-blowing, wormholes. Yeah, you heard that right. These aren't just sci-fi concepts from movies like Interstellar. They're actually rooted in real science. But here's the kicker. What if I told you these cosmic shortcuts that could let us travel millions of light years in just minutes? Sounds insane, right? Stick around because by the end of this video, you'll not only understand how wormholes work, but also why they might be our best shot at exploring the universe. Let's get into it. So, first things first, why are we even talking about wormholes? Well, think about this. Our universe is huge, like incomprehensibly massive. For example, the closest galaxy to us, Andromeda, is about 2.5 million light years away. Now imagine trying to get there with today's technology. Even the fastest spacecraft would take over 94 billion years to reach it. That's longer than the age of the universe itself. And sure, we dream about traveling at the speed of light someday, but guess what? Even at light speed, it'd still take 2.5 million years to reach Andromeda. So yeah, space exploration as we know it has a big problem. Distance. It's almost impossible for humans to explore other galaxies unless we find a shortcut. And that's where wormholes come in. Alright, so what exactly are wormholes? Think of them as cosmic tunnels or bridges connecting two distant points in space-time. Imagine folding a piece of paper and poking a hole through it. That's basically how a wormhole works. Instead of taking the long route across the paper, or in this case, space, you can zip straight through the tunnel and pop out on the other side. Now, this idea didn't just come out of nowhere. It all started with Einstein's theory of relativity. Back in 1915, when Einstein published his famous field equations, he laid the groundwork for understanding how matter and energy affect the curvature of space-time. Fast forward to 1935, and Einstein teamed up with Rosen to propose something wild: Einstein-Rosen bridges. These were essentially early theoretical models of what we now call wormholes. But hold up, there's more. To visualize this, picture a giant mesh fabric representing space-time. When you place heavy objects on it, like planets or stars, the fabric bends. A black hole, for instance, creates such intense gravity that it warps space-time into a deep pit. But what if that warp doesn't just stop there? What if it loops back and connects to another point in space? That's your wormhole, a shortcut through the cosmos. Now, here's where things get really interesting. If wormholes exist, they likely need two ends, one entrance and one exit. On one side, you've got a black hole pulling everything in, including light. But on the other side, scientists theorize there could be something called a white hole. What's a white hole, you ask? Well, it's basically the opposite of a black hole. While black holes suck everything in, white holes spit everything out. Nothing can enter a white hole, but anything inside it can escape. Crazy, right? This concept was first proposed by Russian physicist Igor Novikov in 1964, and while it's still purely theoretical, some scientists believe white holes might explain certain astronomical events we don't fully understand yet. For example, in 2006, NASA's Swift Observatory detected a mysterious gamma-ray burst known as GRB 060614. Unlike typical bursts caused by collapsing stars, this one had no visible source. Some researchers suggested it could be been evidence of a white hole, but we'll probably never know for sure. Still, the possibility is fascinating. Okay, so far we've talked mostly about gravitational wormholes. But guess what? Scientists have already created magnetic wormholes in a lab. In 2015, researchers used special materials to separate the north and south poles of a magnet, creating an invisible gap between them. Essentially, they built a device that mimicked the behavior of a wormhole, for magnetic fields at least. While this isn't quite the same as a space-traveling wormhole, it shows that manipulating fields and creating shortcuts is theoretically possible. Who knows? Maybe one day we'll figure out how to scale this tech up and use it for intergalactic travel. And speaking of futuristic tech, let's talk about the Alcubierre drive. Proposed by physicist Miguel Alcubierre in 1994, this concept involves contracting space in front of a spacecraft and expanding it behind, allowing the ship to surf through space faster than light without breaking any laws of physics. Sounds like science fiction, but hey, if wormholes can exist, why not this? Alright guys, that's it for today's deep dive into wormholes. Pretty wild stuff, huh? If you enjoyed this video, don't forget to smash that like button and subscribe to the channel for more mind-bending science content. Oh, and before you go, drop a comment telling me what you think about wormholes. Do you think they'll ever become a reality? Or is faster than light travel just a pipe dream? Let's chat in the comments. I read every single one. Thanks for watching, and I'll see you in the next video. Peace out.